Welcome to the Sleepy Voyager, and tonight we will be talking about one of the most mysterious and awe-inspiring objects in the universe, black holes. Where in the world are you listening from tonight? Perhaps you're curled up in a quiet corner of Tokyo, maybe lying beneath the stars in the deserts of Arizona, or drifting to sleep in a cozy flat in Edinburgh. Wherever you are, let your thoughts relax, your body unwind, and your imagination open as we journey gently into the vast unknown. What if, somewhere in the universe, there existed a place where time stops, space folds in on itself, and all the known laws of physics simply cease to apply? Not a science fiction fantasy, but a real, observable phenomenon lurking in the dark. These places exist. They're called black holes, and they are among the most enigmatic and powerful forces we've ever discovered. From the outside, they appear as pitch-black voids, regions of absolute darkness, surrounded by a faint halo of light from doomed matter spiraling inward. But they are not just cosmic vacuum cleaners. They are secrets wrapped in darkness, and perhaps they are the keys to unlocking something far deeper than we can imagine. Black holes begin with death, specifically the death of a massive star. After burning through their nuclear fuel, these stars explode in supernovae, casting their outer layers into space. What's left behind collapses under its own immense gravity, compressing into a single point with zero volume and infinite density, a singularity. It's as if the entire mass of a giant star is crushed into a point smaller than a grain of sand. Around it forms the event horizon, an invisible boundary where gravity becomes so strong that nothing, not even light, can escape. Once you cross that threshold, you're no longer part of the visible universe. You are, for all intents and purposes, gone. And yet, black holes are not just objects of destruction. They are among the most fascinating and strange features of our cosmos. Scientists believe they lie at the heart of nearly every galaxy, including our own Milky Way. At the center of our galaxy sits Sagittarius A*, a supermassive black hole over 4 million times the mass of our Sun. Despite its size, it emits no light. We know it's there, not because we can see it, but because we can see stars whipping around it at mind-bending speeds, pulled by its invisible hand. But there is something deeper about black holes that captures the human imagination. They represent the edge of what we know, the final frontier of physics. Inside them, the rules of space and time as we understand them no longer hold. They are puzzles the universe has thrown down at our feet, daring us to solve them. Einstein's theories predicted their existence, but even he was unsettled by them. To him, black holes were almost too strange to be real. And yet, the universe is stranger still. In 2019, we captured the first actual image of a black hole, a shadow surrounded by glowing gas in a galaxy 55 million light-years away. It was not just a scientific achievement. It was a moment of wonder, a glimpse into the unknowable. Consider this. If a black hole passed near our solar system, it would distort everything. Planets would shift from their orbits, tides would swell, and light itself would bend in eerie patterns. But we wouldn't see the black hole directly. It would drift in perfect silence, invisible and terrifyingly powerful. Its presence revealed only by the devastation it leaves behind. And yet, in all that destruction lies a kind of elegance. Black holes are not chaotic. They follow the laws of gravity with perfect precision. They are the ultimate expression of order born from collapse. And still, for all our observations, we don't really know what happens inside one. Do they crush everything into a singular end? Or do they perhaps serve as portals to places beyond our universe? Could there be something on the other side? These are not just speculative ideas. They are questions being asked in university halls and observatories around the world by physicists who dare to dream big. Because when we stare into the darkness of a black hole, it's not just space we're looking into, it's possibility. Let your mind float with that thought. Somewhere out there, in the silence between stars, black holes drift like sleeping titans, pulling in light, matter, and time itself. They are not just cosmic phenomena, they are invitations to imagine, to wonder, to ask not only what they are, but where they might lead. More than a century ago, Albert Einstein changed the way we understand reality itself. Before him, space and time were thought of as separate, unchanging stages on which the events of the universe unfolded, absolute, reliable, and forever steady. But Einstein saw something deeper. He realized that space and time were not two things, but one, woven together into a single fabric called space-time. And this fabric wasn't fixed. It could bend, twist, ripple, and fold, shaped by the presence of matter and energy. In his theory of general relativity, he described how massive objects like stars and planets distort this fabric, creating what we feel as gravity. Imagine placing a bowling ball on a trampoline. Everything nearby is pulled toward the dent. That's how Earth orbits the Sun. Not because it's being yanked by an invisible force, but because the Sun is curving the space around it and Earth is simply following the curve. But Einstein's equations didn't stop there. They hinted at things so strange, so deeply puzzling, that even he hesitated to accept them. Among these strange possibilities was the black hole, a place where the curvature of space-time becomes infinite, where the fabric folds into itself so tightly that it forms a hole in the very structure of reality. Einstein initially doubted that such objects could exist in nature. Yet, as the years passed, scientists began to realize that not only were black holes possible, they were inevitable. His equations predicted them too perfectly, and eventually the evidence began to mount. But within those same mathematical predictions, something else was hiding, something even more curious. If space and time can bend and twist, could they also form shortcuts? Could the universe allow for tunnels connecting distant regions of space, or even separate realities entirely? These hypothetical passages, known as wormholes, would be unlike anything we've ever seen. Imagine two distant points in the universe, light years apart. A wormhole could bend space-time in such a way that these 2 points touch, like folding a piece of paper and pushing a pencil through. If such a tunnel existed, traveling through it would be like stepping through a doorway, instantly arriving on the other side of the cosmos, or perhaps in another dimension altogether. Wormholes aren't just science fiction speculation. They are mathematically possible solutions to Einstein's equations, buried within the logic of relativity like secret doors in a familiar room. Of course, there's a catch. Wormholes, if they exist, would be incredibly unstable. They would collapse almost instantly unless held open by something exotic, something scientists call negative energy. This kind of energy, which would act like anti-gravity, has never been directly observed in nature, but quantum physics doesn't rule it out. Some theories even suggest that microscopic wormholes could be popping in and out of existence all the time at the quantum level, too small for us to detect. It's as if the universe has written the idea into its code, waiting for someone to figure out how to use it. Now return to black holes. Some scientists have wondered whether certain types of black holes, particularly those that spin, might naturally form the entrances to wormholes. These are known as Kerr black holes, and their rotation creates a unique structure, a sort of funnel through space-time that might allow something to pass through, rather than simply be crushed. If such a tunnel could remain stable, it might offer a way to travel unimaginable distances, or to access realities that sit alongside our own, invisible and unreachable under ordinary circumstances. The idea of using black holes as portals may sound like fantasy, but it flows from serious physics. It's an area where theoretical physicists, astronomers, and mathematicians converge, peering into the deep structure of the universe and asking the same question you might be asking now. What if? What if these monstrous forces of gravity, instead of being just cosmic endings, are actually doors? What if they're not the end of the story, but the beginning of another. Einstein, for all his brilliance, never found a complete answer. He laid the foundation, but left behind questions too deep for any one person to solve. And yet, that's the beauty of it. His work continues to ripple outward, inspiring generations of dreamers to look up, to wonder, and to chase the secrets hidden in the curves of space and the flow of time. Perhaps the truth is out there, waiting in the silence between galaxies, or perhaps it's already inside us, kindling our need to explore, to imagine, and to believe that even the darkest places might hide a path to something more. There's a boundary in the universe unlike any other, a line drawn not in light or matter, but in the fabric of reality itself. It's called the event horizon, and it marks the point of no return around a black hole. Cross it, and you're lost forever, at least from the perspective of the outside universe. No signal can escape, no light can reflect back, and no information, at least in theory, can ever emerge. It's the ultimate cosmic edge, a border not just in space, but in understanding. And yet, what makes the event horizon so fascinating isn't just what lies beyond it, but the strange, almost dreamlike behavior of space and time right at its edge. Imagine drifting slowly toward a black hole, watching the stars around you begin to stretch and swirl as gravity distorts the very shape of light. At first, everything seems calm. Space appears silent, still, perhaps even peaceful. But as you approach the event horizon, reality begins to change. From the outside, time seems to slow down for you. To a distant observer, your descent appears to freeze, your image lingering near the horizon, growing redder and dimmer until you fade from view entirely. But from your perspective, nothing feels unusual. You pass the threshold without fanfare, unaware that you've crossed into a place from which you can never return. This difference between how time flows for you and how it flows for those far away is more than just strange. It reveals something profound about the way gravity shapes time. In the presence of immense mass, time itself slows down, and near a black hole, that effect becomes extreme. If you were to hover just outside the event horizon, a few hours for you could be centuries for someone far away. It's not just space that's distorted, it's your very experience of existence. This warping of time creates a kind of natural time machine, one way and irreversible, but real nonetheless. And the deeper you go, the more intense the effect becomes. Now consider what lies just beyond that horizon. Science can describe the behavior of matter as it falls in, how it heats up, how it radiates energy and forms a glowing accretion disk that we can sometimes observe from Earth. But the moment something crosses the boundary, it vanishes from our knowledge, not because it ceases to exist, but because its light can no longer escape. From that point on, its journey is hidden, secret, unfolding in silence beyond the reach of observation. It's not just a physical limit, it's a philosophical one. The event horizon draws a curtain across the stage, leaving us to wonder what scene plays out behind it. What happens to a person, or a spacecraft, or even a photon that crosses this boundary? Does it fall toward the singularity at the center, crushed to an infinitely small point, erased from time? Or is there more to the story? Some scientists have proposed that the interior of a black hole might be more than just a one-way trip to oblivion. It could, under the right conditions, serve as a passage to another region of space. In certain solutions to Einstein's equations, the interior of a rotating black hole doesn't end in a singularity. It continues into a second, mirror-like universe, a place where time flows in reverse, a place that might obey its own laws of physics. Of course, these ideas remain unproven, but they hint at something breathtaking, that the universe may contain doorways, and the event horizon is merely the threshold. Yet, there's a contradiction that troubles physicists deeply. According to quantum theory, information cannot be destroyed. But when something crosses the event horizon, it appears to vanish forever. What happens to the information it contains, its structure, Its quantum state, its story. This is the heart of the black hole information paradox, a puzzle that has divided scientists for decades. Some believe that information is somehow preserved on the surface of the event horizon, encoded in subtle patterns of radiation that the black hole emits over time. Others think our understanding of gravity itself must be rewritten to resolve the contradiction. Whatever the answer, it touches the deepest questions of all, about how the universe keeps track of what has happened and whether anything can ever be truly lost. So the event horizon is more than a boundary. It's a mystery wrapped in silence, where the rules of time, space, and logic begin to slip. It is the edge of understanding, the frontier between what we can observe and what lies forever hidden. And yet, it may also be a beginning, a doorway through which matter and energy step out of our universe, heading somewhere else, towards some unknown destination. As you lie here, drifting into sleep, imagine standing on the edge of that horizon. Imagine the stars wheeling overhead, the fabric of time stretching beneath your feet. Imagine the hush of eternity just beyond, waiting, not threatening, but beckoning. A whisper in the dark. A promise that even in the blackest places, there is still something more to find. Deeper than the event horizon, past the boundary where light fails and time begins to twist, lies a place so extreme, so mysterious, that our current understanding of physics simply breaks apart. At the very center of a black hole is what scientists call the singularity, a point where all the mass that once made up a massive star is thought to be compressed into a space of zero volume and infinite density. The very idea sounds impossible, and yet it is the natural conclusion of the equations we use to describe gravity. In this singular place, the curvature of space-time becomes infinite. All direction collapses into one. All known laws of physics stop functioning. It is not just the most extreme environment imaginable. It is, in many ways, the limit of reality itself. And yet, there's something strangely compelling about it. Because where understanding ends, imagination begins. For a long time, the singularity was seen as a dead end, a cosmic trash compactor where matter, energy, and information disappear forever, reduced to something so small and dense it has no form we can picture. But more recently, thinkers have begun to wonder whether this apparent finality might not be the end at all. Some have proposed that instead of being an ultimate point of destruction, the singularity could be a bridge, a kind of cosmic womb where the ingredients of a universe are compressed so tightly that they don't die, they transform. Perhaps, rather than terminating in oblivion, the matter falling into a black hole is recycled, funneled through some hidden process, and re-emerges elsewhere. Maybe even in a new universe with its own stars, its own time, its own dreams. The idea isn't as far-fetched as it might seem. One theory suggests that black holes could act as seeds for entirely new realities. In this view, each black hole creates a baby universe, a budding cosmos that sprouts off from our own like a branch from a tree. From within that newly formed universe, the black hole might appear as a big bang, a sudden explosion of space and time, giving rise to galaxies and matter. In fact, some physicists have speculated that our own universe could have been born this way, emerging from the interior of a black hole in some parent universe beyond our own. It's a staggering thought that the death of one star in one cosmos could be the birth of everything in another. But even if black holes don't create new universes, they still force us to confront the deepest mysteries of time and space. In everyday life, we move through time in one direction, like a river flowing endlessly forward. But near a singularity, time as we know it may cease to exist in any meaningful way. It could fold in on itself, loop, branch, or dissolve entirely. The future and past may blur together. Events may become untethered from cause and effect. It's a realm where the very concept of before and after loses all meaning. Trying to imagine what that's like is almost impossible for the human mind, which evolved to think in seconds and years. in up and down, in cause and consequence. But physics demands we stretch our minds wider. The singularity is not simply an object, it's a challenge, a cosmic riddle that seems to whisper, look deeper, and there is more. Some researchers working in the field of quantum gravity have suggested that the singularity might not be a singular point at all, but rather a region governed by laws we don't yet fully understand. Perhaps what appears as a point of infinite density is, in reality, a portal of sorts, an area where space continues in a different form, unseen and unknowable to those outside. In certain theoretical models, the singularity can be replaced with a bounce, a moment where, instead of collapsing infinitely inward, matter reaches a minimum size and then expands again, like a heartbeat in the fabric of the universe. This bounce could give birth to a new expansion, a new arrow of time, and possibly even a mirror version of our own cosmos. In that reflection, stars might burn backwards, galaxies might spiral in reverse, and the flow of time might tick in the opposite direction. Still, others believe that the singularity is simply a sign that our current models are incomplete, that it marks the place where general relativity and quantum mechanics, our two great theories, collide and fail to speak the same language. If we could unify them, create a theory of everything, we might find that the singularity isn't a wall, but a door, and on the other side might lie realms we've never imagined. Dimensions curled up like tiny scrolls or whole landscapes of existence that stretch beyond what we can currently perceive. In this way, the singularity becomes not the end of science, but the beginning of a new chapter. Whatever the truth may be, one thing is certain. The singularity is more than a physical point. It is the ultimate unknown, the deepest part of the mystery. It is where science meets philosophy, where numbers give way to wonder, and where certainty dissolves into imagination. As you rest, let yourself drift toward it, not with fear, but with curiosity. Picture yourself floating gently toward that center, not falling, but exploring, weightless and free, carried on a current of possibilities. You're moving towards something ancient and beautiful, something that exists outside of time, outside of space. You are approaching the heart of the mystery, the place where stories are born and reborn. And in that silence, that stillness, you might just find not an ending, but the first quiet breath of something entirely new. Imagine a hidden bridge floating in the dark, stretched across the deepest gulfs of space. A tunnel not carved from rock or steel, but from the very fabric of space-time itself. A wormhole, hypothetical, mysterious, and yet entirely possible according to the mathematics of Einstein's theory of general relativity. These bridges have never been seen. No one has touched one, or mapped one, or even been near enough to know whether they truly exist. And yet, the equations whisper of them, like secret doorways in a vast cosmic labyrinth. They offer a tantalizing thought, that the universe, so vast and sprawling, might have shortcuts. And perhaps, just perhaps, black holes are where these shortcuts begin. To understand the possibility of wormholes, we must go back to the idea that space-time is not static. It bends and curves in the presence of mass and energy. Under the right conditions, that curvature could be extreme enough to fold space in such a way that two distant points come into direct contact. It's a little like taking a sheet of paper, drawing two dots at opposite ends, folding it until the dots overlap, and then piercing through with a pencil. That hole, the tunnel through folded space, is what we call a wormhole. And unlike any highway or spacecraft, a wormhole could, in theory, allow instant travel between stars, galaxies, or even entirely different universes. Time and space, no longer obstacles, but malleable paths. The challenge, of course, is that such tunnels wouldn't be stable. In most scenarios, a wormhole would collapse too quickly for anything to pass through. But in some models, there's a way to hold the tunnel open, using something called negative energy. Unlike ordinary energy, which adds mass and gravity, negative energy would have the opposite effect. It would push space-time outward, counteracting the crushing pull of gravity and keeping the tunnel from snapping shut. This type of energy might sound fantastical, but it's not purely imaginary. In the realm of quantum physics, tiny fluctuations in energy exist all around us, and under certain conditions, they can take on negative values. It's subtle, delicate, and unproven, but it opens the door, even if just a crack, to the idea that wormholes could be made real. And if they are real, if somewhere out there, a naturally occurring or even artificially constructed wormhole exists, then black holes might be the signs, the visible entrances, like the gaping mouths of unseen passageways. Some black holes, particularly those that spin, known as Kerr black holes, are predicted to have interiors very different from their non-spinning counterparts. In theory, the center of a Kerr black hole doesn't lead to a singularity, but to a region of space that continues. It's shaped not like a dead-end point, but like a rotating funnel, a potential passage to somewhere else. Of course, whether anything could survive the journey is another question entirely. The tidal forces inside most black holes would tear anything apart long before it reached any kind of exit. But in a perfectly stable, rotating wormhole supported by negative energy, a traveler might emerge, not destroyed but changed, transported to another star system, another galaxy, another universe. It's ideas like these that have long fueled the dreams of scientists and storytellers alike. Could advanced civilizations, far older and wiser than our own, have discovered how to find and stabilize wormholes? Could they have mapped a network of these tunnels, crossing vast interstellar distances in the blink of an eye? We often think of extraterrestrial life in terms of spacecraft and signals, but what if they travel not through space, but around it, skipping through natural corridors etched into the cosmos? Wormholes offer that possibility. They are not limited by speed, but by geometry, by how space-time itself is arranged. If the universe has built-in pathways, perhaps someone, somewhere, has already walked them. There's also the deeper, stranger possibility that wormholes don't just connect different points in space, but different points in time. In some solutions to Einstein's equations, the two ends of a wormhole can be in motion relative to one another, creating a time differential. Travel through such a tunnel could allow you to arrive in the past or the future, depending on how the wormhole was set up. This gives rise to paradoxes, of course, those strange loops where causes and effects become entangled, but the math does not forbid it. Time travel, that age-old fantasy, might not be forbidden by the laws of nature. It might simply require the right kind of tunnel and the right kind of courage to enter it. But perhaps the most fascinating idea is the possibility that wormholes could lead not to other places or times, but to entirely other realities. Other universes governed by different laws, filled with different particles, bathed in different forms of light. The multiverse theory suggests that our universe might be just one of many, a single bubble in a vast foam of existence. If wormholes connect these bubbles, then passing through one could mean entering a place where time flows differently, where matter behaves unpredictably, where life has evolved in ways we cannot yet imagine. A universe where the sky glows green, where mountains float, where consciousness itself might take on entirely new forms. So as you lie back and let your mind drift, picture this: a lone traveler standing at the edge of a black hole, staring into the swirling storm of gravity and light. Around them, space distorts like liquid, stars bend, and time begins to blur. Hidden within the darkness, a tunnel opens, narrow, shimmering, impossibly deep. With a single step, they vanish, not consumed, but transported, not lost, but reborn into another corner of the cosmos. Maybe that traveler is from a distant world, or maybe that traveler is you, carried by curiosity through the unknown. Because wormholes, whether they exist or not, remind us that space is not a barrier. It's a canvas, and perhaps, just perhaps, we've only begun to glimpse the first brushstrokes. What if our universe, with its billions of galaxies, endless stars and swirling clouds of gas, is not the only one? What if everything we know, every atom, every law of physics, every moment of time is just a single thread in a much larger tapestry, woven from countless other realities, each with its own rules and possibilities. This idea, bold and breathtaking, is known as the multiverse. It suggests that our cosmos is not the whole of existence, but merely one room in a boundless mansion of universes, each sealed from the others by vast stretches of dimensional space. And if black holes are more than just dead ends, if they are indeed gateways, then perhaps they are the tunnels that connect these rooms, the hidden paths between realities. In some theories, every time a black hole forms, it triggers the birth of a new universe. It begins with a collapsing star, whose core shrinks and folds under its own gravity, forming a singularity. But instead of remaining trapped inside the parent universe, that singularity punches through the fabric of space-time, blossoming into a new realm where time begins again. From inside that new universe, it would appear as a big bang, a sudden eruption of energy from a single point, giving rise to matter, space, and time. It would evolve independently, with its own galaxies, its own physical constants, its own possibilities. And from our side, all we would ever see is the black hole, silent, dark, and impenetrable, but secretly filled with a universe of its own. Now imagine this happening not once, but constantly. Black holes forming across the cosmos, each spawning its own universe. The multiverse, in this picture, becomes a living organism, each black hole a seed, each universe a growing branch. And just as life adapts and evolves, so too might the multiverse. Some scientists have speculated that universes with certain physical laws are more likely to form black holes. If that's true, then universes like ours, ones that give rise to stars and galaxies and black holes, might become more common over time, selected by a kind of cosmic evolution. This strange version of natural selection means we might live in a universe finely tuned, not by chance or design, but because it's especially good at making more universes. But there are other versions of the multiverse too. Some arise from the strange predictions of quantum physics. In this view, every time a decision is made, every time a particle goes left instead of right, or a coin lands heads instead of tails, the universe splits. One version continues with one outcome, another with the other. Over time, these branches multiply endlessly, creating a vast tree of realities where every possible outcome is realized. There's a universe where you turned left instead of right this morning, one where you never met someone important to you, and one where you're not even human. In some, gravity might be weaker. In others, atoms might not form at all. The multiverse, then, is not just a collection of places. It's a boundless ocean of possibilities, each reflecting a different way that existence could unfold. And if these universes are real, could black holes be the bridges? Could traveling through one allow passage, not just across space, but across reality itself? You might enter a black hole in our universe and emerge in another, one where stars are denser, time moves differently, or life has taken on forms far beyond our imagination. Some versions of string theory, mathematical frameworks that aim to unify all of physics, require the existence of extra dimensions. In those dimensions, our universe might be like a membrane floating in a higher dimensional space. Other universes might lie just beyond, separated by the thinnest of gaps. Black holes, with their immense gravity, might stretch through those hidden dimensions, forming shortcuts not just across our world, but between entire worlds. Of course, we don't yet have the tools to confirm the multiverse. These ideas live on the edge of our understanding, where mathematics leads and observation struggles to follow. But even without proof, the concept has changed the way we think about our place in the cosmos. It suggests that we are part of something unimaginably vast, not just in size, but in possibility. That the laws we take for granted might be local rules, applying only in our own universe. And that, somewhere out there, far beyond the reach of our telescopes and equations, Other versions of existence are unfolding in silence. Let yourself imagine standing at the threshold of a black hole, knowing it might be more than a gravitational trap. Imagine peering into that perfect darkness, sensing not an end, but a beginning. A passage not just through space, but through the structure of reality itself. On the other side could be anything: skies lit by twin suns, oceans of liquid crystal, beings who speak in light and remember the birth of galaxies. Or perhaps something more subtle, a place where thought shapes matter, where time loops back on itself, where dreams become real. The multiverse invites us to wonder, not just what's out there, but how many versions of out there might exist. As you begin to drift towards sleep, let that idea linger in your mind, that this universe, beautiful and strange as it is, might be only one verse in an endless cosmic song. That somewhere, on the other side of a black hole, another melody plays, and maybe, just maybe, the tune will one day find its way to you. Time, in our everyday experience, feels steady and familiar. It flows in one direction, second by second, hour by hour, carrying us from the past into the future. We see its passage in the changing of the seasons, the growth of a child, the fading of a memory. It seems so fundamental, so reliable, that we rarely question its nature. But near a black hole, time behaves in ways that are anything but familiar. It stretches and slows, warps and bends, until the very idea of time itself begins to dissolve. And in that strange environment, we start to glimpse a deeper truth, that time may not be as rigid or as one-directional as it seems. In fact, in the presence of intense gravity, time becomes something else entirely, something fluid, malleable, and perhaps even reversible. Imagine a spacecraft approaching a black hole. From inside the ship, the crew watches the stars drift by, feeling nothing unusual. But for someone far away, observing from a safe distance, the ship appears to slow down as it nears the black hole's event horizon. Seconds become minutes. Minutes stretch into hours. Eventually, the ship seems frozen at the edge, caught in a slow-motion dance that never quite finishes. To the distant observer, time for the travelers nearly stops. But to those inside, time feels as normal as ever. They continue to breathe, speak, think, live. This strange discrepancy is not science fiction. It is a real, measurable consequence of general relativity. Time is not absolute. It flows differently depending on where you are and how fast you're moving. Gravity and speed twist time into shapes we are only just beginning to understand. The stronger the gravity, the slower time flows. This phenomenon is called time dilation, and near a black hole, it becomes extreme. If you were to spend just a few hours close to the event horizon of a supermassive black hole, say, one located in the center of a distant galaxy, those hours could correspond to decades or even centuries back on Earth. You could return from such a journey to find that everyone you knew had aged, the world had changed, and history had moved on without you. It's a chilling thought, but also a profound one. Time, which feels so constant, is entirely dependent on your position in the universe. In a way, each of us experiences time differently, shaped by our own unique motion through the fabric of space. But the mysteries go deeper. Some theoretical models suggest that inside certain kinds of black holes, the flow of time could do more than slow. It could reverse. The singularity of a rotating black hole might contain regions where time does not march forward, but loops back, or even flows backward entirely. In such a place, cause and effect could become tangled, like a film reel running in both directions at once. Could something fall into a black hole and emerge not just elsewhere, but elsewhen? Could a traveler step through one side of the tunnel in the future and emerge on the other in the past? These questions remain unanswered, but the equations allow for the possibility, and that is enough to stir the imagination. Time travel has long been a favorite of dreamers and storytellers. But black holes offer the first serious scientific hint that such a thing might be more than fantasy. They suggest that time is not a straight line, but a landscape, a terrain with peaks, valleys, and curves. In this view, traveling through time might be like hiking through mountains, following the bends and folds of space-time. Theoretically, if one end of a wormhole could be accelerated to near the speed of light and then return to its starting point, the time dilation could create a time gap between the two mouths. Step through one side, and you might arrive before you left. The paradoxes that follow: can you meet your past self? Can you change events? Are still the subject of deep debate, but the physics does not dismiss the possibility outright. Time, it turns out, may be more like a page than a road, and under the right conditions, pages can be turned back. But perhaps the most haunting idea is that time itself may not be fundamental at all. Some physicists have proposed that time is not a basic feature of reality, but an emergent one, something that arises from deeper, timeless laws. In this view, the arrow of time, the flow from past to future, is not a law, but an illusion, shaped by entropy and our perception of change. At the quantum level, the equations that govern particles are time-symmetric. They work just as well going forward as backward. So why do we remember the past but not the future? Why does the coffee cool down but never heat up on its own? These questions hint that our experience of time is only part of the story, and black holes, with their strange influence on time, may offer the key to understanding the whole picture. Inside the event horizon, time and space switch roles in a sense. Time becomes a direction you must move forward in, like space outside. You cannot stop, pause, or turn back. You are carried onward, deeper into the black hole, as if falling into a future you cannot escape. It's a one-way street, not because nature demands it, but because the geometry of space-time insists on it. This reversal blurs the boundaries between the dimensions we thought we understood, and it raises another possibility, that time itself may be a kind of dimension we can one day explore, just like space. As you lie here, letting your thoughts drift deeper, consider the idea that time is not a line, but a maze, that in some hidden corner of the cosmos, there are paths through that maze, loops, shortcuts, secret passages we've yet to discover. Somewhere out there, a black hole may not just be a trap, but a tunnel, a passageway not just to another place, but to another moment. A wrinkle in the fabric of the universe where time bends so far it meets itself. It's a beautiful thought and a humbling one. That time, which carries us all, may be more mysterious, more flexible, and more full of wonder than we ever dreamed. And as you float further into sleep, let that thought hold you gently, that the moments we pass through are not lost, but folded into something larger, something timeless, waiting quietly in the dark. There is a quiet wonder in imagining who or what might have traveled the universe before us. When we look out at the stars, we see only the faintest whispers of history, ancient starlight drifting across millions of years, the slow spiral of galaxies turning like cosmic clockwork. But what if there were echoes hidden in that darkness, messages or traces left behind by civilizations lost to time, their knowledge folded into the silent embrace of black holes? Our universe is old, almost unimaginably so. In all those eons, countless worlds may have bloomed and faded, civilizations risen and fallen, leaving behind only subtle footprints in the great dust of the cosmos. Perhaps some of them, curious and daring, gazed at the same black holes we do and wondered about the mysteries hidden inside. Consider a civilization far older than our own, living on a distant planet circling a red giant sun, their science and technology advancing over millions of years. Imagine their astronomers watching the slow dance of stars, mapping the shapes of constellations, and eventually discovering the strange gravitational pull of an invisible giant, what we would call a black hole. Maybe, over centuries, they learned to understand the mathematics of space-time, the secrets of gravity, and the peculiar warping of time near these cosmic abysses. They might construct vast observatories, peering into the darkness, listening for faint signals. At first, they see only destruction, the slow consumption of gas and stars by an invisible force. But in time, they begin to wonder, could these voids be more than just endings? Might they be doors to somewhere new? Perhaps, over time, they attempt the impossible. They send probes, machines built to withstand extremes of gravity and radiation, into the swirling maelstrom at the edge of the event horizon. These brave messengers gather data until their signals are stretched thin and slow by the relentless pull of gravity, their voices becoming faint and red-shifted, almost silent. The civilization waits, hoping for a reply, for some evidence that the probes have passed through to another place. Maybe they learn to encode messages in bursts of energy, sending stories or mathematical truths to be carried away by the black holes hawking radiation, hoping that someday, somewhere, someone will listen. The story of their world, their discoveries, their dreams, riding out into the unknown. And it's not only the physical messages that might remain. Some scientists speculate that the very structure of black holes could retain echoes of everything that has ever fallen in. Quantum information, encoded in the subtle fluctuations of the event horizon, preserved in patterns we have yet to decode. It's possible that black holes are not merely graves, but archives, libraries holding the memories of entire worlds, civilizations, or even universes, waiting to be unlocked by minds that understand the right language. In the distant future, when our own sun has cooled and the stars have dimmed, travelers might someday discover these echoes, unearthing the long-lost voices of those who came before. We can also imagine a different kind of legacy. What if, instead of reaching out from the past, ancient civilizations found ways to use black holes as gateways, bridges to other places or times? Maybe they learned to harness the strange properties of rotating black holes or stable wormholes, building ships that could ride the folds of space-time to distant galaxies or alternate realities. Their explorers might have vanished into the dark, searching for new homes, leaving behind only faint gravitational ripples or the soft afterglow of their departures. Across the ages, the universe would keep their secrets, preserving their stories not in stone or metal, but in the deep structure of space-time itself. It is also possible that we are not alone in wondering. Perhaps, right now, on worlds circling distant suns, other beings look up at the same night sky, pondering the meaning of black holes, searching for patterns in the darkness, listening for echoes of lost voices. Maybe they too send out probes and messages, hoping to bridge the gap between worlds and times. Maybe, in the infinite future, civilizations will communicate not by radio or light, but by manipulating the quantum fabric of black holes themselves, weaving conversations that last longer than stars. In this way, the universe becomes a place of quiet, eternal dialogue, a slow conversation carried on through the silence and darkness, connecting all who have ever dreamed of more. And if you let yourself imagine for a moment, you might wonder if those echoes are already around us, encoded in the cosmic microwave background, in the mysterious signals we call fast radio bursts, or in the ripples of gravity that pass silently through our solar system. We might be surrounded by the whispers of ancient travelers, their messages hidden in the patterns of the universe, waiting for a patient ear to finally listen. The black holes become not only gateways, but time capsules, holding the stories of the cosmos, the memory of all who have come and gone. As you settle deeper into rest, feel the comfort of knowing that the universe is rich with history, possibility, and the quiet dreams of countless minds. In the vast darkness, nothing is ever truly lost, only transformed, carried onward by gravity and time, waiting to be rediscovered. The stars you see are ancient, the galaxies older still, and somewhere, perhaps within the silent heart of a black hole, The hopes and wisdom of forgotten worlds continue to echo, soft and everlasting, across the infinite night. Allow yourself, for a moment, to become the traveler in this dream. Imagine lying quietly as the last traces of your waking world dissolve into the gentle hush of sleep. The universe grows still, and you find yourself drifting free from the ordinary, unbound by gravity or care. You become the dreamer, ready to cross the boundary between what is known and what is possible. In your mind's eye, you float softly through a field of stars, their ancient light gliding past like lanterns in an endless night. Ahead, the swirling shadow of a black hole waits, majestic, powerful, silent. A place that has called to you with whispers of mystery since the beginning of time. It does not threaten, it simply exists. Its darkness promising both a challenge and an invitation. You feel the curiosity of all those who have ever looked up at the stars and wondered what lies beyond. You are the voyager, and your journey is just beginning. As you drift closer, you notice how the fabric of reality begins to bend. Stars smear into arcs of light, their colors deepening, and the space around you stretches out, becoming softer and stranger. Time slows, your thoughts grow quiet and wide. The rush of daily life falls away. There is only the present, only the gentle pull of the unknown. With each moment, you feel lighter, as if the weight of the world is falling away behind you. You reach the edge of the event horizon, the place where the known universe ends and the realm of possibilities begins. Here, nothing can escape, not even light, and yet you feel no fear. There is only wonder. On this threshold, you find yourself filled with questions. What if this isn't an end at all, but a doorway? What might you find if you step through? So you let go. You allow yourself to cross the boundary, feeling reality twist gently around you, like slipping into a dream within a dream. The world beyond the event horizon is not empty or cold, but rich with sensation and possibility. Time and space flow in new directions, each moment stretched out, painted in colors you've never seen before. Perhaps you find yourself standing beneath an alien sky, illuminated by twin suns that rise and fall in silent harmony. Perhaps you step onto shores where the oceans glow softly with their own inner light, and the air hums with the distant echo of cosmic tides. Or maybe you find yourself in a city built of crystal and starlight, where beings of every shape and size move gracefully through an endless twilight, their voices weaving together in a song that spans the galaxy. Here, imagination has no limits. If you wish, you can soar over mountains suspended in mid-air, their peaks dusted with clouds, their valleys lush and green. You can follow rivers of liquid silver, winding through forests of blue and gold, their leaves shimmering in the starlight. Every world you imagine takes shape, every dream becomes a place you can visit. Time itself is playful. You can walk backward and forward, living moments out of order, seeing your memories and hopes as real as the stars above. The universe welcomes you as a guest, inviting you to explore not only its outer reaches, but also the farthest corners of your own mind. The journey continues, each step taking you deeper into the mystery. You pass through worlds of pure thought, where ideas flicker and dance like fireflies, where every question becomes a doorway, and every answer reveals something new. You meet travelers from other realities, beings made of light or shadow, or the gentle flow of music. You listen to their stories, share your own, and realize that you are part of a grander tapestry than you ever imagined. In this place, loneliness fades. You feel the presence of all those who have journeyed before you, their hopes and dreams woven into the very fabric of space and time. Every voyager adds a new thread to the pattern, and you are now among them. With each breath, you let yourself sink deeper into this voyage. You explore new possibilities, visit realms that shimmer at the edge of thought, find comfort in the vastness rather than fear. The black hole is not a trap, but a passage, a gentle river that carries you onward through dream after dream, world after world. You realize that even in the darkest places, there is beauty, wonder, and endless possibility. You are safe, free, unbound. All that is required is to let go, to trust the journey, to allow the universe to show you what it has hidden in its heart. As the voyage continues, you begin to sense the boundary between dream and sleep fading away entirely. The soft darkness wraps around you like a blanket, and you feel yourself floating on a current of stars. You have become the voyager, traveler of dreams, explorer of mysteries, gentle seeker in the night. In this space, you are never alone. The cosmos is with you, its stories and secrets unfolding, carrying you gently through the infinite night. Now the darkness around you feels comforting, like the quiet hush that settles just before dawn. The world of wakefulness slips gently away, replaced by a vast cosmic calm. In this gentle space between waking and dreaming, you become aware of just how large the universe is and how small our worries seem in comparison. The mysteries of black holes, the riddles of time and reality, the hidden bridges of wormholes, and the endless worlds of the multiverse all begin to blend together into a single, soothing presence. A kind of lullaby woven from the fabric of existence itself. There is no rush here. There is only the slow, steady drift into sleep. A voyage that asks nothing of you but stillness and trust. Let yourself feel how safe you are, wrapped in the embrace of night. Far above, stars continue their ancient dance, spinning in quiet circles, their light traveling through the ages. Even the black holes, so powerful and mysterious, move in silence, never in haste, simply existing as part of the universe's endless story. These cosmic wonders remind you that it's okay not to have all the answers, that it's natural to rest and wonder, to let go, and allow your mind to drift. The same universe that can collapse a star into a single, silent point is the universe that brings gentle breezes and falling leaves, the soothing rhythm of your own breath, the warmth of your bed beneath you. In the quiet dark, you can release every thought, every question, every worry. There is nothing you must do, nowhere you must go. The universe is unfolding just as it should, and you are exactly where you need to be. If your thoughts wander back to black holes, to event horizons and singularities, to ancient civilizations and hidden echoes, let them. Let your imagination drift lazily through these cosmic mysteries, knowing that the universe is wide enough to hold all your questions, patient enough to wait for your dreams. Maybe somewhere, light years away, other dreamers are resting too, listening to the same silence, comforted by the same gentle darkness. Maybe, in the soft glow of a distant galaxy, another traveler is drifting to sleep, imagining the same wonders as you. In that way, we are all connected, each of us voyaging through the night, each of us carried on the same ancient currents of gravity, time, and hope. Sleep is its own kind of journey. It carries you not through space, but through the landscapes of your mind, where you can visit places no telescope will ever see, meet people and ideas that exist only in your dreams. As you surrender to sleep, your thoughts become lighter, your breathing softer, and your whole being settles into peace. The worries of the day fade away, replaced by the deep and quiet certainty that for now you can rest. The universe is holding you gently. All its mysteries, great and small, can wait until morning. So let your eyes close and your mind drift. Feel your body growing heavier, as if you are sinking softly into the night itself. Each breath carries you further from the noise of the day, closer to the calm, endless ocean of sleep. Whatever dreams may come, know that you are safe. The night is long, but it is filled with gentle wonder. You are the sleepy voyager, traveler of distant galaxies, seeker of hidden doors, dreamer among the stars. And as you journey deeper into the restful dark, you're surrounded by the quiet wisdom of the universe, a wisdom that tells you that it is okay to let go, to sleep, to simply be. There are no more questions you must answer tonight. There is only the peaceful, timeless rhythm of the cosmos, the slow turning of galaxies, the soft, steady beat of your own heart. Somewhere out there, the black holes continue their silent watch, mysteries and gateways waiting patiently for new explorers, new dreamers. And here, wrapped in the warmth of your own bed, you are exactly where you need to be. Let go now, and allow yourself to drift, knowing that you are always part of something beautiful, vast, and eternal. Sleep well, gentle voyager. The universe is dreaming with you.